I welcome you all to our second session. And our first speaker is Florian Brandl. Florian, the floor is yours.
Okay, thanks. Thanks for the opportunity to give this talk. This work combines aspects from social choice and decision theory. So what I will look at here is how to aggregate preferences under uncertainty. So the setting is as follows. We have multiple agents, each of whom has preferences over uncertain acts. And we would like to study how to aggregate these preferences into collective preferences over the acts. And my approach to this question will be axiomatic. So we'll consider aggregation functions and then impose axioms on them and study which aggregation functions satisfy these axioms. So the first question is how to model uncertainty. For this, I will use Savage's model of decision-making under uncertainty. The primitives there are a set of states and a set of outcomes. And an act is a function from states to outcomes. Okay, and then we want to look in a particular class of preference relations over these acts, namely those which are based on subjective expected utility. They are given by a belief, which is a probability measure on the set of states, and a utility function on the outcomes. And then to compare two acts, we calculate their expected utility, and whichever one has the larger expected utility according to that belief and that utility function is more preferred. The second primitive in my model will be a set of agents, and a preference profile is a tuple of SEU preferences for some subset of the agents. In particular, I will allow for variable sets of agents. And lastly, I consider aggregation functions, which map a preference profile to an SEU preference. So the collective preference will also be assumed to be subjective expected utility maximizing. Okay, so here is an example for this. The story behind it goes as follows. There are two gentlemen who have been feuding, and in order to resolve this, they are contemplating holding a duel. So there are two possible acts. Either they could decide to hold the duel, or they could cancel it. Second, there are two states of the world. The first state is that gentleman 1 is stronger, and the second, that gentleman 2 is stronger. And we have three outcomes. If they decide to hold the duel and gentleman 1 is stronger, then 1 will win and 2 will get injured. So this will be good for 1 and very bad for 2. Similarly, if they hold the duel and gentleman 2 is stronger, and there is a third outcome, which obtains if they decide to cancel the duel, irrespective of the state of the world. In that case, they remain at the status quo, which means each of them maybe loses a bit of reputation, but it's not too bad for either of them. So here is a table which gives examples of beliefs and utility functions for this case. Here we have that gentleman 1 puts a very high probability on the state where he is stronger, so he's very confident. And similarly, gentleman 2 is very confident in his abilities. And second, gentleman 1 has utility 1 for winning the duel, and then 0 for the status quo, and a large negative utility for losing the duel. And similarly, slightly different numbers for gentleman 2. So in a sense, both their beliefs and utility functions are opposed here. Now we'll get back to in a moment what's the point of this example. But let me first state what's about to come. So I want to impose axioms on aggregation functions. And what we will end up with is a characterization of one particular aggregation function that I call belief averaging and relative utilitarianism. It works as follows. We derive an aggregate belief by averaging the agent's beliefs, and we derive an aggregate utility function by summing up the agent's utility functions. And then those together give us collective preferences. However, if I have stated this, this is not well defined, because the preferences of an agent determine their utility function only up to positive affine transformations. So if we want to add up utility functions, we need to say which one we choose given an agent's preferences. And what belief averaging and relative utilitarianism does is it normalizes each agent's utility function to the unit interval and then adds them up. The main result of this paper is that this aggregation method is the only anonymous aggregation function that satisfies two axioms called restrictive monotonicity and independence of redundant acts. Independence of redundant acts is a weakening of Arrow's independence of irrelevant alternatives. Roughly, it only applies to subsets of acts that are, in a well-defined sense, very large. And restricted monotonicity roughly works as follows. Say we have some preference profile for a subset of the agents. We aggregate their preferences and we find, according to those collective preferences, they're indifferent between two acts. And then we add an additional agent to this profile who prefers the first of those two acts. Then under certain restrictions for the augmented profile with the additional agent, if we aggregate preferences, then they should prefer the first act. In other words, this additional agent gets to break the tie that was present in the original collective preferences. So let's see how this works in the example. We average the beliefs, which gives us what's shown here in the table. And then we normalize the utility functions to the unit interval. So the original utility, the non-normalized utility functions are in gray and the normalized ones in black. And then we add them up. Together, this aggregate belief and aggregate utility function give us the collective preferences. In this case, if we calculate expected utilities, we find that canceling the dual has a higher expected utility than holding the dual. So collectively, like society would prefer canceling the dual. Now, what may be a bit strange here is that if you look at each gentleman's preferences individually, you will find that each of them prefers holding the dual over canceling the dual. So what we have here is a violation of the Pareto principle. Now, however, it has been argued in this literature that we don't necessarily need to be worried about such violations when aggregating preferences that are based on subjective expected utilities. What we have in this example is what Philippe Monchat called a spurious unanimity, a unanimous preference for one act over another that's based on very different beliefs and very different utility functions. And then these differences cancel out each other and lead to the same preferences over the acts. And for this reason, we don't necessarily want the Pareto principle to apply to these to such acts, because one reason would be one could say that they're based on the fact that at least one of the agents has a severely mistaken belief. In addition, Monchat has proven that if one insists on the Pareto principle for subjective expected utility preferences, then aggregation is simply impossible. So even just for a single preference profile, it's not possible to find an aggregate preference relation that satisfies the Pareto principle unless all agents have the same belief, in which case we are back to the setting of regular expected utility. Here is a bit more on related literature. So I've divided these results into single profile results and multi-profile results. Single profile means we only look at one preference profile in isolation and consider axioms that only talk about one preference profile, like the Pareto condition. Multi-profile results are the ones that reason about aggregation functions and impose axioms on them that relate different preference profiles. First here, for expected utility preferences, we have Hassani's social aggregation theorem, which states that the only way to aggregate linear utility functions over lotteries and to satisfy the Pareto principle is by taking a linear combination of those utility functions. Now, as I mentioned, this doesn't work out for SEU preferences. However, Gilboa, Sammet, and Schmeidler found a weakening of the Pareto condition, which they call a restricted Pareto optimality, which only applies to acts about which all agents have the same beliefs. And they showed that this restricted Pareto condition is equivalent to linearly aggregating beliefs and utility functions. Now, Hassani's result has been extended in a different way, namely to the multi-profile case, by Dillon and Mertens, who characterized relative utilitarianism, which is aggregating utility functions over lotteries by first normalizing them to the unit interval, as I explained previously, and then adding them up. So the characterization of belief averaging and relative utilitarianism in this paper can be seen as either extending Dillon and Mertens' characterization to the case of SEU preferences, or as a variant of the result by Gilboa and others to the multi-profile case. Okay, so the plan for the rest of the talk is as follows. Next, we'll be introducing the model, in particular SEU preferences and aggregation functions. Then I will talk about the aggregation, the axioms I make on aggregation functions, state the main result, and maybe I have time to do a brief proof sketch, and conclude with a few points for discussion. So this slide will be entirely on Savage, just recalling Savage's subjective expected utility. So we have a set of states and a set of outcomes. Both are measurable, and acts will be measurable functions from states to outcomes. And then we have SEU preferences, which are given by a belief and a utility function. Belief is a non-atomic probability measure on the set of states. Non-atomic means that for every event that has positive probability, you can find a smaller event that still has positive probability. The second ingredient is a utility function, which maps from outcomes to real numbers and is assumed to be measurable and bounded. Boundedness is important here because we want to normalize utility functions, and it's not clear how you would do this normalization if you don't have bounded utility functions. And then to compare two acts, we calculated the expected utilities according to some belief and some utility function. Now, in this representation of a preference relation by a belief and a utility function, the belief is uniquely determined. However, the utility function is only unique up to positive affine transformations. So for the purpose of this talk, it will be convenient to, when we represent a preference relation, to always take the utility function that has infimal utility value 0 and supremal utility value 1. Okay, but for now, this is just an arbitrary choice. It just makes it more convenient to state the final result. Okay, and all preference relations that we will encounter in this talk are SEU preferences, particularly also collective preferences. A preference profile is a tuple of SEU preferences indexed by some finite subset of the natural numbers. So agents are identified with natural numbers, and we only consider preference profiles on finite sets of agents. And an aggregation function maps every preference profile on an arbitrary subset of agents to a collective preference relation. I will introduce two pieces of notations that will be convenient. Given some preference relation, I will denote by pi subscript the relation, the unique belief associated with it, and by u subscript the relation, the unique normalized utility function. And if we have the preference relation of some agent I, then I will simply write pi I for the associated belief and similarly for ui. Okay, so now let's talk about some axioms on the aggregation functions. I will start by introducing restricted monotonicity. So let's say we have some subset of agents and a preference profile for them and aggregate their preferences. And let's say according to the collective preferences, we find that they're indifferent between two acts F and G. And then we have an outside agent, J, who prefers F over G. And then this axiom talks about what happens if we add J to the profile. Now, I will impose a restriction here, namely that that F induces the same lottery over outcomes for the belief of agent J and the aggregate belief that's associated with the collective preferences for the preference profile on the left. So this means that if we look at the push forward measure of the belief of J under F, so this is a lottery over outcomes, and we do the same for the aggregate belief for the preference profile on the left, then those two lotteries over outcomes coincide. And similarly for G. So intuitively, both beliefs, like differences between both beliefs are irrelevant for F and G. And the reason for doing this is to avoid these spurious unanimities that I mentioned earlier. So now restrictive monotonicity says, in such a case, if we add J to this profile and again aggregate preferences, then the collective preferences should have F preferred to G. Good. And it's not hard to verify that in addition with an axiom that I will with a simple axiom that I will introduce in a minute, restricted monotonicity implies the restricted Pareto condition by Gilboa and others. The second main axiom is independence of redundant acts. So first, what do I mean by a redundant act? I will say that a subset of acts calligraphic A is co-redundant for a profile P if for every act there is some act in A so that every agent is indifferent between the two acts. Okay, so one way to visualize this goes as follows. In the example here, we have a profile on two agents, which induces a mapping from acts to the plane. Because for every act, we can look at what's the expected utility of the first agent and the second agent, and this gives us some point in the plane. So let's say the set of points we can get in this way is the blue area here. And by the way, this will always be a convex set. Now, what makes a set of acts co-redundant is if we restrict this mapping to the set A, then we still hit every point in this blue area. So the image is preserved under restricting to the subset of acts. Another way to look at this is that the set of acts A is rich enough so that we can still achieve every utility profile that we could achieve by any act. So in a sense, co-redundant sets are very large. And now independence of redundant acts essentially takes Arrow's independence of irrelevant alternatives and says it should only apply to subsets of acts that are co-redundant. So here it is. Say we have a co-redundant subset of acts for two preference profiles. And every agent has the same preferences over the acts in A in both profiles. Then it should be the case that the collective preferences over the acts in A are the same in both profiles. If we were to omit this first condition here, that A is co-redundant, then we would get back to Arrow's IIA. Okay, are there questions about these two axioms? So if you have any, feel free to shout out. Okay, then let me move on to three further axioms, which are easier. The first one is faithfulness, which says that for any single agent profile, the collective preferences should be the preferences of the single agent. Second, no belief imposition, which says no agents can dictate the collective belief. And lastly, we want the collective preferences to depend continuously on the agent's preferences with respect to a certain topology on preferences. So then here's a precursor of the main result that I noted previously. It says that every aggregation function that satisfies the 5 axioms above is weighted belief averaging and weighted utilitarian. This means it works as follows. To every agent, we assign 2 weights, 1 weight for their belief and 1 weight for their utility function. And these weights are fixed across all preference profiles. And then given any preference profile, we derive an aggregate belief by a weighted average of the agent's beliefs and an aggregate utility function from the weighted sum of the agent's utility functions. Now, what's different compared to the results of Hassani and Gilboa and others is that these weights here are fixed across all preference profiles. Their results just made a statement about a single preference profile, but it could be the case that in their case, the weights change arbitrarily between preference profiles because they have no condition that connects profiles. And then it's a simple corollary of this, that if we additionally impose anonymity, the only thing that's left is belief averaging and relative utilitarianism. So anonymity gives us that that the weights of all agents have to be equal, so we might as well choose them to be equal to 1. And then we get back to the unweighted average of beliefs and just the regular sum of utility functions. Okay, so I'll briefly sketch how the proof of this result goes. So here's an outline of the main steps. First, one observes that the restrictive monotonicity condition, together with the faithfulness axiom, implies the restricted Pareto condition. Now, we know that the restricted Pareto condition implies linear aggregation of beliefs and utility functions for within every single preference profile. In other words, we get a function that to every preference profile associates a weight for the belief of every agent And similarly, we get another function that for every preference profile associates a weight to the utility function of every agent. Okay, so we have weights that can depend on preference profiles. The first main step will be to use restrictive monotonicity. This will imply that the weight of every agent can only depend on their own preferences, but not on those of other agents. And the second step is using independence of redundant acts to show that the weight of an agent cannot depend on their own preferences either. So here is an outline of how the step from the weight can depend on all agents' preferences to only the agent's own preferences goes. And I will do this for the weight function of for the utility functions. So we are given this weight function, and we want to show that it's independent, that for agent I, it's independent of the part of the preference profile corresponding to agents other than I. Now, the idea is to use restricted monotonicity to show that the ratio of the weights of two agents cannot depend on the preferences of a third agent. And then from this, it will be easy to get the desired conclusion. So we do this by considering some profile on three agents, let's say. We want to compare it to the profile where we removed the third agent. And what we would like to have is that the ratio of the weights of the first two agents didn't change by doing this. So let's look at the aggregate utility function for the three agent profile. And we will consider two different ways of writing that. So first, we look at the aggregate utility function for the two agent profile. And then we observe that what restricted monotonicity allows us to do is apply the restricted Pareto condition to the case where one preference relation is an aggregate relation and the other one is that of an additional agent. And it tells us that if we apply restricted monotonicity, then the resulting collective preferences have to be a linear combination. Or the resulting aggregate utility function has to be a linear combination of the utility function for the smaller profile and the additional agent. Okay, now we know that the utility function for the two agent profile can be written in the way that's stated on the top right here. So we know that we can use the weight functions for the two agent profile to write it as some linear combination of the utility functions of the first two agents. Now, this is the first way of writing this collective utility function. The second way is directly appealing to the representation on the top right. So then we get the linear combination with the weights for the three agent profile. Okay, and now let's assume for a second that all the utility functions are linearly independent. Then we get that the weights in both combinations need to be the same. In particular, it gives us that the ratio of the weights for agents 1 and 2 are the same in both profiles. Okay, so this is the line stated here. And doing this for every triple of agents and also for larger profiles with the same idea essentially, one can show that it's possible to redefine the weight function so that the weight of agent 1 doesn't change by removing the third agent from the profile. This gives us that the weight of the first agent is independent of the preferences of the other agents. Okay, so in the interest of time, I will be a bit quicker about the second step and just give a very rough idea. So we have shown that the weight functions of every agent can only depend on their own preferences. Now we would like to show that they're in fact constant if we, in addition, impose independence of redundant acts. Let's assume we have already shown that the weight function for the belief is constant and that the weight for this agent's utility function is independent of their belief. So what we are left with is a weight function for the utilities that only depends on the agent's own utility function. And we'd like to show this is constant. The two main ideas here are, first, to apply independence of redundant acts to show that particular changes to an agent's utility function don't change the weight. And then for any pair of utility functions, construct a path between them so that for every step along this path, we only make these particular changes to the utility function that don't change the weight. And then this clearly gives us that it has to be constant. Okay, so to leave some time for questions, I will skip the explanation here and move on to some discussion points. So first, one question that you could ask is, what are alternative ways to aggregate preferences in this setting? Now, there has been a characterization of what's called ex-ante utilitarianism by Brumont. So ex-ante relative utilitarianism works as follows. Given any act, we calculate so first we again normalize every agent's utility function to the unit interval. And then given any act, we calculate the agent's expected utility for that act. And then we add up these utilities across all agents. And then acts are ranked according to these sums of expected utilities. Now, it will typically be the case that this resulting preference relation is not based on subjective expected utility. So strictly speaking, this aggregation function is not part of my model. And roughly, what happens in Brumont's characterization is that he makes weaker assumptions on the collective preferences. In particular, he doesn't assume their SEU preferences clearly, but he makes stronger assumptions about the aggregation function. For example, he uses the full Pareto principle, and he uses a stronger version of the independence of redundant acts axiom that I presented. Another alternative way to aggregate preferences that fits into my model is geometric linear aggregation, which was characterized by Dietrich in a recent paper. So here the belief is aggregated geometrically. So we assign a weight to every agent, and then for every act, for every state of the world, we look at the probability that some agent assigns to it, and then take the geometric mean of these probabilities with respect to the agent's weights. Well, it's called geometric linear because the utility functions are in fact aggregated linearly. In order to characterize this kind of aggregation, Dietrich has a weakened form of the Pareto axiom, so even weaker than restricted Pareto. And he uses consistency with Bayesian updating, which says that it should not make a difference if we first aggregate preferences and then update the collective belief on some new information, or if we first update all agents' beliefs on this new information and then aggregate preferences. So this kind of axiom makes sense if you're in a setting with where new information arrives over time.
Florian, sorry for interrupting. There are just 5 minutes left. Please leave some time for questions.
Yes, I will conclude now. So I wanted just to point out that The restrictive Pareto condition rules out some sorts of spurious synonymities, but there are some left which Mosha and Pivato calls complementary ignorance. So roughly what happens there is that agents have different private information, and the spurious synonymity arises because of different private information. But if each of them were to have all of the information, then the unanimous preference would vanish. So this is a sort of spurious synonymity in a setting with private information. And then lastly, I would like to point out two non-obvious consequences of the axioms that we get from the characterization. The first one is neutrality on outcomes. And the second one is that beliefs and utilities are aggregated separately. So in principle, you could have that the aggregate belief depends on the agent's utility functions or vice versa. And it's not immediately clear from the axioms that something like this is not permitted. Okay, thanks for your attention.
Thank you, Florian. There is a question from Hervé.
Thank you, Florian. I mean, very precise and clear. You may have mentioned that, but do you get from your theorem as a corollary Dillon and Mertens?
Yeah, so unfortunately I don't, because so one reason is that I'm considering aggregation functions on a larger domain. So I just have many more preference profiles because I consider SEU preferences. So I can also use these additional profiles in arguments in the proof. So this is why I don't get this as a corollary. However, if one looks at the main steps in the proof, it would not be too hard to derive their result by following these steps.
But they have to make then some extra assumptions vis-a-vis your stuff, no?
They have an axiom that's very similar to the independence of redundant acts. So basically just more or less the same axiom. And then they have also some sort of monotonicity condition. So the axioms are not directly comparable. So for example, their results are for a fixed agenda, whereas mine is variable, fixed electorate, whereas mine is variable electorate. But it's roughly similar.
Okay. Thank you. Thanks.
Maybe
you're muted, Fedor.
Yeah, go ahead.
Hi, I just I think Bahel and Sprumont have a paper on the strategic problem, right, where you get something very different. So you have SEU preferences, but at the end of it, you just choose some general, you choose an act, and then you have something very different. So I was also sort of wondering why it is compelling to assume that the output of your aggregator is SEU as well, right? And then, that imposes a lot of restrictions, doesn't it? I mean, yeah.
Yeah, okay. So, so roughly what I'm assuming here is that we have the same level of rationality on the individual as and also on the collective level. So I also want collective decisions to be rationalized by subjective expected utility. But you're right that this is kind of a demanding assumption, in particular in view of this result that it's incompatible with Pareto optimality. So it's really a question of which one you are willing to give up.
Thank you.
Fedor, I think you are muted.
Oh, I I see. Thank you, Florian.